Hi everyone. Wish you a very good morning and a warm welcome from OTT HydroMet team. During these tough times, we hope you, your family, and teams are safe and healthy. Hello, I'm Abhinash, Marcom Manager for HARC and OTT HydroMet from Bangalore office. We have today Mr. Matthew and Mr. Holger with us, and they are from the OTT HydroMet Meteorological Product Management team. During this session today, we'll have a detailed outlook on ceilometer basics, applications, and success stories. Some rules for the webinar: all the participants will be permanently on mute. Session shall be recorded and will be shared with all the registered participants. Chat box to be used for questions during the webinar. Questions shall be answered after the webinar ends, and we'll have a question answer session. We'll follow up for all the open and rest of the questions which go unanswered. Yeah. Over to you now, Matt, for the presentation. Hope you all have a great session.
Very good. Can you hear me all right?
Yes, Matt, we can hear you.
Thank you. Thank you, Avinash. And hello, everyone. I'm Matt Corey, and on behalf of Holger and myself, welcome to this presentation on ceilometers. The agenda today will be who we are, why choose OTT HydroMet, some basics on ceilometers, an intro to the CHM 8K ceilometer, the CHM 8K versus the CHM 15K, which ceilometer should you use? And ceilometers can be used in many different applications, and we'll focus a bit on the solar industry. And finally, some sample applications that have successfully used our ceilometers. Before we talk about OTT HydroMet and ceilometers, I thought it would be good to introduce ourselves. Holger and I represent the product management team here at OTT HydroMet in meteorology. Holger holds a degree in physics and is a certified product manager. He has a long history of working in the field of LiDAR and nonlinear beam propagation. Holger has had a successful career, which started in 2002 working with research and development as an engineer developing ceilometers, then as a product manager and business unit manager. And today, he is the guy that we all rely on for his technical expertise as our lifecycle product manager in meteorology. For myself, my name is Matt Corey. I'm the global product manager for meteorology. I've been in this position for about 6 months now. I have a degree in atmospheric science and business administration. I was a chief meteorologist for 20 plus years in the United States. I've built products for the weather industry and companies in New Zealand and in the Netherlands. And the industries I have built weather products for include energy, aviation, roadways, offshore, shipping, mining, and many more. What gets me up in the morning is taking on the challenge of applying science to help people make better decisions. And today, I'm excited to talk to you about ceilometers. And I will try to not only explain what does a ceilometer do, but also give some ideas of what could it do for you. Okay, that's a bit about who we personally are. What about OTT HydroMet? Who are we? More than a pretty picture. OTT HydroMet, we measure the world's surface weather, and water cycle. We offer a wide range of proven meteorologic and hydrologic solutions that can be combined to bring complete solutions to our customers. Our solutions prove time and again their value in protecting lives, property, and our environment. Have we been around long? Yes, I'm always amazed at the long lineage of our products. OTT's first current meter was in 1875. Luft's first barometer was in 1909, and Kip and Zonen's first pyranometer is in 1927. So the takeaway from this slide is that we've always been innovators to bring quality products to solve our customers' problems for almost 150 years. Even though our solutions have been applied to many different applications, there are some clear categories that our typical customers align with. meteorology and climatology, where we help government weather services and climatologists with highly reliable monitoring solutions. Renewable energy, solar, wind, and hydro solutions for resource and performance monitoring. Roadway and runway solutions, providing precision snow, ice, and water monitoring. Agricultural solutions, helping farms maximize their production. Why choose OTT HydroMet? At OTT HydroMet, leading today, investing in tomorrow. Why choose us? Trust, 500 plus years of combined experience in environmental monitoring. Commitment, we provide that latest in technical solutions and help you realize economic and sustainability goals. Providing solutions, we partner with our customers to achieve results. And reliability, with our global organization, we provide reliable data with world-class support. Why choose us? From global to local, we'll make your project happen, no matter the project size. And finally, why choose OTT HydroMet? Strength. OTT HydroMet is a part of the water platform of Danaher Corporation, which is a global science and technology innovator. And it had $21 billion in revenue in 2019 and over 60,000 associates around the globe. The take home is, we're here to stay. Okay, on to the topic at hand, ceilometers. And that leads us to audience participation question 1. Have you used a ceilometer? Yes or no? Avinash?
Thanks, Matt, for giving the question. So all the participants, this is the first question that you have on your screen. I'll just read it out again. Have you used the ceilometer? Yes or no? The question will come onto your screen in a few moments. You'll have 30 seconds to vote for this question. So I'm launching it now. So please select the answer. You have 10 seconds more. Another 5 seconds. And that's it. So I'm closing the poll now. Sharing the results. So we have 71% who says no, they have not used, and 29% says yes, they have used a ceilometer. Over to you, Matt.
Okay, great. All right, moving on. What is cloud height measurement? Based on the LiDAR principle, a ceilometer transmits a laser light pulse into the atmosphere. Laser light is then scattered by molecules, particles, and droplets through the different levels above the sensor. A very small amount of the light is back scattered to the ground, and this enables the instrument to process the timing and intensity of the light to create a backscatter profile. And this profile is how the altitude of the particles and aerosols are determined. Now that we know how a ceilometer basically does its job, let's discuss why would someone want to measure aerosol and cloud layer heights. Typical use cases of a ceilometer: aircraft safety. Cloud heights and visibility are extremely important for aircraft landing and taking off from airports. This historically has been done by people taking a survey of the sky on an hourly basis. Challenges come from consistency and accuracy of these manual reports, especially at night. A ceilometer can perform a continuous monitoring of cloud heights and visibility 24 hours a day. Another application: public health and environmental uses. Detecting the boundary layers in the atmosphere is a critical function for determining density and transport of pollutants. In certain atmospheric conditions, especially low-level inversions, these dense, low-lying layers can be a considerable health threat. Additionally, ceilometers can be used to detect smoke, ash, and particulate layers at higher altitudes, enabling tracking to the sources and the trajectories. Another application is in meteorological services. Forecasters can use the data from ceilometers to issue warnings of fog, visibility, cloud cover, and precipitation events. Modelers use ceilometer data to validate their model predictions and initializations for increased model accuracy. And ceilometers are also used for volcanic plume monitoring, which can affect everything from aircraft safety to global energy budgets. Now we know the use cases. Who would use a ceilometer? Well, airports, especially for lower cloud-based monitoring, which would be critical for takeoff and landings. Helicopter pads, incredibly important to know the vertical visibility and cloud heights, especially during night operations. Environmental protection agencies for tracking of fine dust and aerosol layers. Meteorological and weather services, fog detection, abilities to see multiple cloud layers, and helping detect volcanic eruptions and ash layers. What makes a good cloud height monitor? Well, it has to be easy to use. A standard user often is not a scientist or an engineer, so the product needs to be easy to install, test, and maintain. All in one unit. Important to have a fully functioning device without having to install and maintain multiple peripheral accessories, computers, or items. Lifetime expectations of 10 to 20 years with minimal maintenance maximizes the investment and value of the unit. Safety. It's important that ceilometers, as a laser product, is eye safe, and so a Class 1M certification is important. A wide temperature range. It's important that the unit can survive extreme conditions, from very cold to very hot. Low level of service is needed. Install it and forget. It should just work with minimal maintenance, and you should be able to trust it. And finally, the ability to detect multiple layers. This might seem obvious, but some ceilometers can't do more than a few layers. The atmosphere is very stratified, and different layers might be critical to the safety and decision process. So it's very important to be able to detect a significant number of layers. Now let's discuss Lufft's newest ceilometer, the CHM 8K. I'm going to highlight some key capabilities here. Its backscatter coefficient effectively enables aerosol layer identification and mixing layer height calculations. The unit returns best in industry, very high precision, false alarm rate less than 1%, and a probability of detection better than 95%. The unit calculates and returns data in layers, cloud base, penetration depths, vertical visual range, and cloud amounts, which satisfies the World Meteorological Organization's requirements for code 2700. It includes sky condition index, giving precipitation and fog, and finally, the unit can detect up to 9 cloud layers. Here's the CHM 8K. I'm going to talk about some hardware highlights. Much of this we discussed in what makes a good ceilometer, such as safety, ease of use, and temperature range, which are all best in class. But an important point here is that the unit requires no external PC for operation. It's entirely self-contained. It includes easy setup and flexible data communications, easily serviceable unit with a modular configuration, so components can be serviced versus needing to service the entire unit at one time. Finally, it meets the 10 to 20 year operation, and with an IP66 rating, it resists not just extreme temperatures, but also extreme water intrusion as well. Communications are extremely important because you need to get the data from the unit effectively and reliably. Configuration of the CHM 8K is easy with a PC, laptop, or data logger. Data can be viewed from an easy web interface, automatic data transfers, and uploads to external FTP servers. Data formats, the CHM unit delivers data in NetCDF, standard for easy ingest. Connections are available through built-in RS-485 and Ethernet DSL. Software is very important. CHM unit data can be accessed directly or by the CHM viewer software. The RS-485 output can produce the data that can be ingested into any software, and even can be used as text-based output. But the CHM software is one of the best ways to view the data, which includes contour plots, displays in correlation with clouds, aerosol layers, and modified overlaps, history and status of parameters, and plot and PDF export functions. Another valuable feature of the CHM software is the sky condition algorithm. The software is embedded in the processing board, not an external add-on, and provides items needed to satisfy WMO code 2700, which includes cloud statistics, penetration depths, uncertainties, octa, sky conditions, this will come up later, precip, fog, and vertical visibility. For accessories, one of the most valuable accessories is the CHM-AK simulator. The simulator checks and verifies the calibration of the unit. It simulates multiple cloud layers and a planetary boundary layer. It's controlled by a tablet or a smartphone app, and it can connect directly to the unit or via Bluetooth. Other valuable accessory is the tilt adapter. This enables the ceilometer to be installed at an angle, which is important when used at less than 30 degrees north or 30 degrees south latitude. This is the CHM-8K summary sheet. We went over a few of these items, but I put it here just for reference. And also this is available on our website at othydromet.com. In the Lufft product line, we have our newest CHM-8K, which we've been talking about, but we also have our tried and trusted CHM-15K. Next, we will highlight some key advantages between the two models. And here we go, key advantages between the 8K and the 15K. The CHM-8K is optimized for highest performance for detection up to 8 kilometers during daylight hours, and go much higher at nighttime. Long-lasting laser diode emitter with lifetime expected greater than 10 years. Advanced status checks and warnings, which include humidity in the housing, voltage parameters, window and detector status, and signal quality. The CHM-15K is the only major ceilometer in the market using 1064 nanometer wavelength, which is free of water absorption effects of the atmosphere. It uses a micropulse laser with best-in-class daylight suppression, very well controlled with high laser beam quality. Wavelength is not shifting with temperature, which enables the unit to be optimized for high altitude detection. The CHM-8K versus the 15K. Overlap and sensitivity. Overlap and the field of view is important for what atmospheric height and level the unit is focused on detecting. The field of view of the CHM-8K is 2.5 times larger than that of the CHM-15K. The results is the 8K is maximized for lower atmospheric levels and the 15K maximized for upper levels. A bit about detection method between the 8K and the 15K units. The CHM-8K uses a continuous analog method with high sensitivity and dynamic range, while the CHM-15K uses a pulse measuring photon method for high sensitivity and good resistance to signal interference for a very clear signal. This slide shows a bit of the outputs of the same location and the same time, and you can see the difference between the CHM-8K and the 15K outputs. The yellow boxes I've put in highlight the focus of the two units. Note the 8K quite clear in the lower levels and more noise for the upper levels, and note the 15K is quite clear in the upper levels, but a little bit more noise in the lower levels. So, which unit should you use for your application? Well, both models have advantages for many use cases, but the CHM-8K, generally, optimization for detection less than 200 meter, is suitable for airports and environmental applications. While the CHM-15K, applications needing high daylight performance for high clouds, aerosol layers, and volcanic ash, tends to be suitable for Met services, research scientists, and environmental monitoring. And here we have another data sheet. You can see the specs and comparison between the two ceilometers. And again, this information is available on our website at othydromet.com. And that brings us to audience participation. Question number 2. What ceilometer would you use for your application? Go ahead, Amish.
Thank you, Matt. Yeah. So question is already there on your screen. I'll just launch the poll for you. Launching now. Which ceilometer would you prefer, 8 kilometer or 15 kilometers? You have 30 seconds to vote. Another 10 seconds. And I'll be closing the poll now. Sharing the results with you. We have 20% voting for 8 kilometer and 80% voting for 15 kilometers. Over to you, Matt.
Great, thank you. All right. Briefly, I'd like to touch on ceilometer use in solar applications. First, I'd like to say that as a meteorologist, I'm impressed with India as one of the most progressive countries in pushing for improved accuracy in forecasting in order to optimize the anticipated power generated by solar and wind energy sources. This helps create a more stable power grid and maximize the efficiencies of renewable energy. To push the forecasting accuracy boundaries, WMS recommendation via the electricity boards and the CERC requires ground-based measurements to be implemented to improve the forecasts for every 15 minutes ahead in the current day and also for the week ahead. Among the many parameters collected and reported by every solar plant operator is cloud cover reported in octa. If you recall, the CHM sky condition algorithm calculates octa, which could be used to satisfy this requirement, but also the ceilometer can do so much more. As a proposal to IMD and other agencies and the QCA companies, current methods for cloud reporting fall short of incorporating multiple cloud detection and aerosol heights and mixing layer heights needed to get cloud density. The challenge that these agencies are trying to overcome is forecasting cloud shadow effects, which means anticipating impacts of weather on available radiation for producing energy. Current methods fall short a bit of this goal because cloud-based mixing heights and aerosol heights are important and are not delivered by cameras or are delivered reliably by forecast models. Model accuracy is often not fine enough for cloud prediction, especially with multiple cloud layers and motions. To illustrate our point here a bit, a sky camera, which is the more standard solution for the solar industry, has limitations for what it can deliver. Sky cameras can get you a total sky cover, but sky cameras cannot get you cloud levels, cloud layers, and the effects of ash, dust, and smoke events. Our recommendation would be a solution that isn't camera or ceilometer, but possibly a camera and a ceilometer to come up with a great solution. Demonstrating this are a few pictures on this page. Note that in the middle area, the drawing, that the sky camera will look up and only be able to see what's in the lower cloud levels and won't be able to detect what's above those cloud levels. Top right-hand image is an actual sky camera image. Note the horizon around the outside. That one really can't get more than the percentage of the cloud cover when looking at an image like this. The bottom right image could be a typical weather day with higher cirrus type clouds moving one way, while the lower cumulus type clouds are affected by different winds and would travel a different direction. Only by knowing the different layers of the clouds would you have a chance to predict where each cloud set is moving. And the bottom left image is a dust event in Spain that was recorded in 2016, which was detected quite well by our ceilometers, but tough to make out on a camera as more of a hazy setup, and thus effects on the available radiation of such a day would be quite challenging. All right, we've covered quite a bit so far about the what, why, how, and who of ceilometers. Now let's look into some samples of successful applications of ceilometers. First up, successful application in government weather network. The customer was the Dutch Royal Weather Service and the German Weather Service, or the DWD. The use cases were civil and military airport managers, flight weather consultants, environmental measurement, climate research, and optimization of weather forecast models. Our solution was KNMI at 50 CHM 15K, both onshore and offshore installations. And the DWD had more than 100 devices of both the CHM 15 and 8K. And the timeline was 2015 to 2021 and still going strong today. Our next successful application is basically an offshoot from previous. It's been aviation. As part of the previous slide, this is more details on the KNMI installation. The 50 ceilometers that were deployed were to support airports and helidecks throughout the Netherlands, civilian and military. And what was needed here was accurate and real-time data, which is essential for supporting regulations, including International Civil Aviation Organization, or ICAO, World Meteorological Organization, which is WMO, and the European Aviation Safety Agency, EASA. And I just want to note that all of these use cases are on our website, so you don't have to look real close into this fine print here. You can look it up on our website at hydromet.com if you're interested in more of these use cases. Our next successful application was in climate change research. The customer was Munich, study to show how a commercial ceilometer aerosol network could fill gaps to determine a spatial aerosol distribution. Our solutions were the CHM 15K and the 8K. Next up, one of my favorites, was an application on a research vessel. The customer, FU Berlin and Max Planck Institute of Chemistry. The study was on board the research vessel, and it was in May through July 2019. Data served to calibrate data for satellite remote sensing and as evaluation data for global modeling. The CHM 8K was used along with the cloud camera to characterize the cloud base, and the CHM 8K's ability for multi-layer detection supported data evaluation for multi-axis differential optical absorption spectroscopy, say that 5 times fast, by validating the aerosol heights. Our next application was in aerosol studies. This customer is Stony Brook University and NASA, and they mounted CHM 15Ks on vehicles to assess snow forecasting by analyzing the inside of turbulent snow clouds called snow bands. NASA sent 2 planes into and above the snowstorms, and the ceilometers were part of the ground-based mobile deployment trucks. Our next example is well, it's kind of a collage of different examples of research from around the world. Meteor Swiss had a CHM 15K horizontal mounting for aerosol distribution and visibility in the Alps. Water quality analysis for climate change research in China. Climate change research in the Amazon rainforest, and you can see them up here, actually has the tilt on it, being close to the equator. University of North Dakota blowing snow study. Aerosol distribution and mixing layer monitoring in Barbados. And the German Kit Institute studies of mixing layer heights in Germany. And I kept last, but certainly not least here, the Indian Institute of Tropical Meteorology, IITM. Several CHM 15Ks were deployed for a multitude of studies and monitoring. Cloud interface studies to detect smog that was interfering with airport operations, which led to more profiles for monitoring ongoing airport operations. And a couple units were deployed for cloud seeding projects for precipitation enhancement experiments. All right, that brings us to our next audience participation question. What is your ceilometer application? 1 is research, 2 weather monitoring, 3 pollution monitoring, or 4 other. Yours, Avansh.
Thank you, Matt. I'll be launching the poll question now for you to answer. Yeah, you can answer now. You'll have 30 seconds. Another 10 seconds to go. And that's it. I'll be closing the poll now. Sharing the results now. So we have 50% going for research, 50% for weather monitoring, and others are 0, and pollution monitoring also as 0. Over to you, Matt, again.
Great, those are interesting stats, thank you. Okay, so a summary. Hope everyone learned something today. I'm gonna go over just a recap of what we had. Who we are OTT HydroMet. We are a sum of many great companies with a long history of successful innovations and solutions. Why choose us? Reliability, strength, and trust. We treat customers as partners and have a strong history of solid solutions. Ceilometer basics. We talked a little bit about how a ceilometer works, why it is important, cloud heights, aerosol heights, applications such as aviation, meteorology, environmental monitoring, and research. We introduced the CHM 8K, industry-leading solution, best in class for accuracy and ease of use. We talked about the CHM 8K versus the 15K, lower atmospheric levels versus upper atmospheric level applications. We talked about the ceilometer used for the solar industry, which is growing, and I think we're just scratching the surface for what a ceilometer could do for this industry. And also some sample applications, lots of solutions, lots of ways ceilometers are used to solve many government, industry, and environmental problems. I guess the last part is what can OTT HydroMet do for you? Thank you.